Hi, I want to continue in this book. This is the last thing I want to do for the moment, anyway. It's about the cosmological argument, and this, like previously, I did a pretty long video about the Kalam Cosmological argument of J.P. Moreland and William Lane Craig, and this video is about. It's discussing a critique of the Kalam Cosmological argument by Paul Draper. And this, in my opinion, states the failing point of. I personally don't think that the Kalam Cosmological argument fails. I think it's a good argument, except that there's things that if one is arguing this, one has to make arguments for the things that Draper discusses here, and he discusses a couple weak points. First of all, in this part he discusses a couple different ones. He discusses the argument from contingency and the Kalam cosmological argument. The argument from contingency: every contingent thing, including things that are infinitely old, has a cause of its existence. 2, the universe is contingent. Therefore, the universe has a cause of its existence. And then he states the Kalam cosmological argument, which to him has a little bit better. It's a little bit more sound, I guess. 1, everything that begins to exist has a cause of its existence. 2, the universe began to exist. 3, therefore, the universe has a cause of its existence. Now, this rests on a couple of different things here. First of all, he discusses, Draper goes over 4 arguments that Craig has, which argues for this argument for God's existence. Craig, however, provides a spirited and plausible defense of this premise. He offers 4 arguments in support of it. He has he's discussing this the first premise. Everything that begins to exist has a cause of its existence. So he discusses these 4 arguments that Craig presents for belief, for arguing this. 2 philosophical ones and 2 scientific. He says both philosophical arguments depend on a distinction between a potential infinite and an actual infinite. This is the big part here. This is the very important thing here. A potential infinite is a series or collection that can increase forever without limit, but is always finite. E.g., the set of events that have occurred since the birth of my daughter, or the set of completed years after 1000 BCE. An actual infinite is a set of distinct things, real or not, whose number is actually infinite, e.g., a set of natural numbers. The first philosophical argument claims that there can't be an infinite regress of events, because actual infinites cannot exist in reality. So that's the first. According to the second, an infinite regressive event is impossible because even if actual infinites could exist in reality, they could not be formed by successive addition. What the heck is going on here? Successive addition being, adding event to a certain collection of events. The first scientific argument is based on the evidence for the Big Bang Theory, which seems to many scientists to support the view that the universe had a beginning. So the Big Bang Theory, this is the the scientific theory that everything was condensed into a small area of space, and then given a lot of energy, it expanded and became what the universe is now. The second scientific argument appeals to the second law of thermodynamics. According to this law, the amount of energy available to do mechanical work always decreases in a closed system. Thus, since the universe as a whole is a closed system with a finite amount of such energy, an infinitely old universe is incompatible with the fact that we have not yet run out of such energy. The universe has not yet reached its equilibrium end state. So, Draper, he starts to look at the second argument that's in favor of the first premises of the first premise of the Kalam argument, which is everything that begins to exist has a cause. Craig formulates the argument as follows. 1. The temporal series of events is a collection formed by successive addition, as in adding one event to the next. 2. A collection formed by successive addition cannot be an actual infinite. Thus, the temporal series of events cannot be an actual infinite, which is an inference from 2 or from 1 and 2. Therefore, the temporal regress of events is finite. He points this out to Zeno's paradox, which is similar to this, which depend on the claim that one cannot complete an infinite series of tasks one at a time, since that would imply an infinitieth number of the series. As it stands, the argument is unconvincing. For while it is true that one cannot start with a finite collection and then by adding one new number at a time, turn it into an infinite collection, nothing of the sort is required in order for the past to be infinite. For if the temporal regress of events is infinite, then the universe has never had a finite number of past events. Rather, it has always been the case that the collection of past events is infinite. Thus, if the temporal regress of events is infinite, then the temporal series of events is not an infinite collection formed by successively adding to a finite collection. Rather, it is a collection formed by successively adding to an infinite collection, and surely it is not impossible to form an infinite collection by successively adding to an already infinite collection. So then Draper discusses possible ejection. If the temporal regress of events is infinite, then there must be some event E separated from the birth of my daughter by an infinite number of intermediate events, in which case the collection containing E and all those intermediate events would have to be an actually infinite collection formed by successively adding to an infinite collection formed by successively adding to a finite collection of events, namely the collection containing E as its only member. This objection fails because it is simply not true that if the temporal regress of events is infinite, then there must be two events separated by an infinite number of intermediate events. For consider the set of natural numbers. It is actually infinite, yet every number of it is such that there is a finite number of members in between it and its first member. Okay. And then Draper goes to the first argument, which is in favor of the first premise. And it's cats are playing. Yeah. He says that it's more promising than the second. It bases its conclusion that the temporal regress of physical events must be finite. There must have been a first physical event on the premises that an actual infinite cannot exist in reality, and an infinite temporal regress of events isn't an actual infinite. From this, and the further claim that a first physical event could not have been preceded by an eternal absolute, quiescent physical universe, the conclusion is drawn that the physical universe had a beginning. The first stage of this argument can be formulated as follows. A. No set of real things is actually infinite. If there was no first event, then the set of all real events occurring prior to the birth of my daughter is actually infinite. Therefore, there was a first event. Craig defends premise A. Premise A again being no set of real things is actually infinite. Of this argument by pointing out that the assumption that a set of real things is actually infinite has paradoxical implications. For example, it implies that we could have a library consisting of infinitely many black books. Each might be assigned an even number. We could then add infinitely many red books. Each might be assigned an odd number, and yet not increase the number of books in the library by a single volume. Indeed, we could add infinitely many different colors of books with infinitely many books of each color. The red books could be assigned rational numbers between 0 and 1, the black books rational numbers between 1 and 2, and so on, and not increase our collection by a single volume. Okay, so we're talking about this is a paradoxical library. We have a library where we have a bunch of black books, each assigned a even number, and then so we have infinitely black books, infinitely many black books, and then we add to it infinitely many red books assigned odd numbers, and we could keep going on from that to adding more and more. But at the beginning, when we had these black books, we had infinitely many black books to start. So, I mean, that's infinite. That's infinitely many black books. So, if you add infinitely many more things, if you add one to infinity, you are not really increasing anything. You just have the same. So this has paradoxes to believing it to arguing a set of real things that are actually infinite breeds these paradoxes. And the reason he says in the first premise no set of real things is actually infinite is because it generates these paradoxes, and because it's paradoxical to have sets of real things that are actually infinite. But then Draper says these paradoxes arise because the following three statements constitute an inconsistent triad. So these premises with the idea that no set of actual infinites can exist. No set of real things is actually infinite. And he says that because of these paradoxes, and these paradoxes are because of this inconsistent triad. S1, a set has more members than any of its proper subsets. So we have a set of and then we have three subsets, which the three subsets make up the set itself. So each of those subsets has less members in it than the whole set itself. S2, if the members of two sets can be placed in one-to-one correspondence, then neither set has more members than the other. This would be also using a term called equinumerosity. Okay. For example, since these then S3, there are actually infinite sets. For example, the set of even numbers has one-to-one correspondence with the set of natural numbers, and even with the set of rational numbers. S2 implies that one could add infinitely many red books or infinitely many books of infinitely many different colors to the library without increasing the size of that library's collection. But of course, S1 implies that any such addition would increase the size of the collection, since the set of even numbers is a proper subset of both the set of natural numbers and the set of rational numbers. Thus, two intuitively appealing principles together imply a contradiction on the assumption that there can be an actually infinite collection of books. So we have S1, which a set has more members than any of its proper subsets. Then we have 2. If the members of 2 sets can be placed in one-to-one correspondence, then neither set has more members than the other. And then 3. There are actually infinite sets. That third one contradicts with the first one. A set has more members than any of its proper subsets. So, let's say we have a set which has infinitely many members, as in the library. Then we have the subset of black books, the subset of red books, and let's say the subset of yellow books. And with this, if we add the even-numbered black books and the odd-numbered red books, which are infinitely many subsets, you have the same amount you have the same amount of books of infinity in the subset as you do in the set. So the third one is contradicting the first. So here's the whole issue here. Draper concludes that Craig fails to show that S1 and S2 are both true of all collections of real objects, and hence he fails to show that actually infinite collections of real objects are impossible. Therefore, his first philosophical argument, like his second, fails to establish that an infinite regress of events is impossible, and so fails to establish that the universe began to exist. This leaves us with Craig's scientific arguments. Since I lack the expertise to evaluate these arguments, but let's assume, for the sake of the argument, that they succeed, and hence that the universe did begin to exist. Must we then conclude that the Kalam argument succeeds? This would be a profound result. Granted, this argument doesn't get all the way to God's existence, but accepting its conclusion does require rejecting naturalism, since nothing can be a cause of its own existence. A cause outside the natural world would be required. So, essentially, here we have a connection with this triad, this inconsistent triad, with the universe beginning to exist. Let's go back to the first premise of the first argument. So, the first premise of the Kalam argument says everything begins to exist. Everything that begins to exist has a cause of its existence. You have to back that up. You have to back up why everything that begins to exist has a cause. In the first there's an argument that Craig makes to back this up, which is A, no set of real things is actually infinite. And this is where, Craig says it's because of the paradoxes that arise from that, and the paradoxes come from this inconsistent triad. So what Craig needs to do, Draper is pointing out that Craig needs to reject the third part of the triad. The third one being there are actually infinite sets, and he needs to reject that one, and then go with the 1 and the 2. A set has more members than any of its proper subsets, and if members of the sets can be placed in one-on-one correspondence, then neither set has more members than the other. So Draper says that he needs to reject S3, the third member of the triad, and he needs to show that 1 and 2 are true, the premise about the subsets and the premise about the one-on-one correspondence that are true, and that the third one is false. And if he cannot do that, then he cannot show that no real things are actually infinite, unless he can't show that things that begin to exist have a cause. He cannot show that. So this is what I think. This is the weak part of the Kalam argument, because the problem is that things cannot be proven to actually be you cannot prove that there are no actual infinites that exist in reality. You cannot prove that unless you reject the third part of the triad. So that is, in my opinion, reading from Draper, that is the weak part of it. That's the weak part of the Kalam argument. Now, can this be done? Can't Craig or anybody else show that S1 a set has more members than any of its proper subsets, and S2 if the members of two sets can be placed in one-to-one correspondence, then neither set has more members than the other, and rejecting that there are actually infinite sets. Now, Craig claims that Georg-Cantor's theory of transfinite numbers is consistent because it rejects the first member. But this member is not rejected because it can be proven false about actually infinite sets, nor is the second member accepted because it can be proven that if a one-to-one correspondence between the elements of two actually infinite sets can be established, then the sets are equivalent. So what Craig has tried to do is he's tried to appeal to Cantor's theory of finite numbers, and that's rejecting the first one, when really what he needs to do is reject the third. And if he can actually do that and prove that there are no actual infinites, then he would if he can prove then he would also be able to prove that no set of real things are actually infinite, and then that would follow to, if there is no first event, then the set of all real events occurring prior to the birth of my daughter is actually infinite. And given he proves this, or someone else proves this, there are no actual infinites. Therefore, there's a first event, and everything that begins to exist has a cause even further. So that's what he has to do. That's the weak part. So yeah, that's I might say some more things about the cosmological argument, but that's pretty much where I'm going to stop for now, anyway. So, thanks.